Hello everybody, welcome to Science Abounds, Science at Home, where we will discover home lab magic. We will perform experiments covering scientific principles, reactions and concepts in chemistry, biology, microbiology, microscopy, and even forensic science. Welcome to my channel. Hello everybody and welcome to Science Abounds, Science at Home, where we will discover home lab magic. In today's video, we're going to be observing a composition reaction. What is a composition reaction? Composition reaction produces a single substance from multiple reactants. The single substance as a product is the key characteristic of a composition reaction. The general formula of a composition reaction is A plus B equals AB. An example of a composition reaction is when hydrogen and oxygen react to form water. This is the reaction that occurs for the formation of water. You have two gases, hydrogen and oxygen, producing a single reactant, a single substance, water. Here, hydrogen and oxygen combine to form water, which is a more complex substance than the individual reactants themselves. In this video, we are going to look at the reaction of two elements, iron and sulfur, which when combined, they react together to form iron sulfide. This is an example of the simplest type of composition reaction, one in which two elements react to form a single compound. Iron, this is a solid metal that is highly reactive when it combines and comes into contact with sulfur. For us to perform this experiment, we're going to do this outside because we're going to be heating sulfur, and you do not want to be heating and producing sulfur fumes inside your home. So let's go outside and do the experiment. Okay, I have everything set up that I need for the experiment. You need a clamp, metal reaction plate, a clay wire gauze platform for your aluminum plate, a Bunsen burner, and you need sulfur and iron filings for this experiment. So I'm going to weigh about 3 grams of iron filings. Okay, so I need about 3 grams. And then I'm going to add about 2 grams of sulfur. Get that right. So I want 2 grams of sulfur. Okay, almost there. All right. 2 grams. All right. Now, what I want you to remember is iron filings are magnetic, and if I stick a magnet in iron filings, it's going to be attracted to the magnet. This is an important characteristic because when we've combined iron with sulfur to make iron sulfate, that magnetism goes away. So what I want to do now is to mix the 2 compounds together and compact them into a compacted pellet before I burn it. So that's what I'm going to do now. So what I want to try and do now is to mix the 2 elements together and then bring them together and compact them down. So right now I'm just going to bring them all together. And then try and compact it all down. Trying to get everything into a little mount. Okay, and then just compact it all down. Okay, now we're going to try and heat that up. So I've got my setup here. So now we just light our burner. And we watch and wait for the reaction to occur. Takes a little bit of time. The mixture is starting to bubble, and the reaction is going to be starting very soon. Let me move this a little bit closer to the camera and away from me. Okay, as you saw, there was brown flame forming, brown smoke coming off. When you see that, that's the reaction occurring. So I've turned off my flame, and now I'm going to let the reaction complete and then cool down. So now the iron sulfate has cooled down. Just to reiterate, when you're heating iron sulfur together, it's a very vigorous exothermic reaction, and you do not want to be breathing in any of the fumes or smoke that's coming off the reaction. So it's very important you perform this experiment outside. So what I'm going to do now is I'm going to transfer the iron sulfide into a pestle and mortar. Okay. And I'm just going to grind that up. And remember, iron on its own is highly attracted to a magnet, but iron sulfide is not attractive to a magnet. It is not magnetized. So I know now the iron has been incorporated into the sulfur to form iron sulfide. This is one of the tests, like a positive reaction, to know that the reaction went to completion and iron sulfide was formed. Another test that we can do is in a test tube have a small amount of hydrochloric acid. Pour that out a little bit. Don't need much. Okay. And that's concentrated hydrochloric acid. And what I'm going to do is I'm going to add the iron sulfide into the test tube. And what I'm going to do is I'm going to gently waft the tube, and you should have a smell of rotten eggs, which I do. Don't sniff the test tube. Don't put your nose over it and take a big sniff. Just waft the air above it, and you should instantly smell sulfur dioxide and the smell of rotten eggs. Sulfur on its own does not react with hydrochloric acid. So again, this is another test that we have formed iron sulfide. So let's recap on today's reaction. Sulfur, as we know, is a non-metal that typically exists as S8 molecules in its elemental form. But in this reaction, sulfur reacts as individual sulfur atoms. Iron reacts with sulfur in a direct combination reaction. The sulfur ions bond with the iron atoms, forming iron 2 sulfide. The product, iron sulfide, as you saw, is a black solid in its pure form. This reaction is exothermic, meaning it releases energy in the form of heat. So what are the key characteristics of composition reactions? Well, key characteristics include the combination of simple reactants. Normally, the reactants are two elements, like in today's experiment, sulfur and iron. You can have a composition reaction between a metal and a non-metal. Again, we had two elements. One was a metal and one was a non-metal. Or from two compounds. For example, calcium oxide and water giving calcium hydroxide is a simple composition reaction. Some composition reactions release energy, i.e. they're exothermic. Others require energy input and are endothermic. Unlike other types of reactions, a composition reaction usually results in a single product. And that's exactly what we saw today by the formation of iron sulfide. no other product was produced from this composition reaction. And that is a key characteristic of a composition reaction. There are several applications of composition reactions. For example, the formation of water. Very simple, but it is a complex reaction. And it is a critical reaction in many natural processes, including combustion and respiration. Composition reactions are very important in the manufacturing of compounds and the formation of alloys, metal combined with other metals or non-metals to form, which forms and allows such that iron carbon can combine to produce steel. Well, I hope you enjoyed today's video and today's experiment. Please hit the subscribe button. It's free, doesn't cost you anything, and it helps support my channel. Also hit the like and share buttons. Check out my Patreon page where I have exclusive videos, exclusive experiments that are not shown on YouTube. And also I publish all my experiment notes and procedures so that you can follow along and do the experiments at home. And that can all be found on my Patreon page. Also, email me your questions, comments. Also, send me your photos, videos of you doing your own home experiments. I love to see other people doing experiments and I love to share. So until next time, keep on experimenting. Goodbye, everybody.